Um, make sure it's recording. So hi, thank you all for being here today, especially with it being a holiday. What better way to celebrate Washington's birthday than discussing energy infrastructure futures for America? There are a wide range of attendees that are going to be joining us in the audience today, from people who work in energy technology fields to people who probably aren't quite sure what a microgrid is yet. With that being said, we have an excellent panel from Ameresco here today to talk about this technology from their perspective. They're going to offer valuable insights and show us their own microgrid in Wayland, Massachusetts. Every week, we're trying to showcase a different perspective for you on microgrids. Last week, we saw the Siemens Russ Electric microgrid at the Innovation Center in Hingham. Today, you'll get the tour and information about the Wayland School microgrid. And next week, on February 22nd, you'll get to see a couple of smaller nanogrid systems that are owned by individuals in Cohasset, Massachusetts. And that'll wrap up February, and then we'll have 3 more tours in March, starting with Schneider Electric on March 1st. For more information, you can go to the Town of Cohasset's Alternative Energy Committee webpage, which has our flyer with the schedule and the registration link. If you like what you see here today, please continue to register and join us for these tours. At the end of the webinar, I'll put the links into the chat box as well so you can sign up again, and I'll also include my email so you can contact me with any questions. During the tour, you can put any questions you have into that Q&A box that's labeled at the bottom of your screen. An Ameresco representative will be moderating the chat, so if your question doesn't get answered during the tour, you can also have the opportunity to ask it live at the end yourself. Once the tour is concluded, we'll give you all the ability to speak, and then you can ask your live questions. And we have a representative here from the Metropolitan Area Planning Council as well, so she'll be able to answer any relevant questions you may have at the end. Also, please keep in mind that today's event is being recorded. So with all that being said, allow me to introduce our presenters and tour guides from Ameresco. We have Jackson Dowdy on the call, who is a project developer providing management of the engineering design, economic analysis, interconnection, permitting and regulatory process, and contractual agreements throughout a project's development timeline. He's responsible for identifying project opportunities and ensuring the optimal project is developed for the client. This may include on-site or remote project management upon execution of engineer procure construct and power purchase agreement contracts. His experience includes development of solar PV, battery energy storage systems, cogeneration plants, and central plants for electricity and thermal energy for various customers, including universities, hospitals, and municipalities throughout the United States. We also have Brian Petro on the call. Mr. Petro is the Director of Design Engineering with more than 18 years of experience in energy engineering. Mr. Petro is responsible for taking a project from the development stage to construction. He is responsible for design and design oversight of solar PV and battery ESS, and specification of material and equipment to be used on projects. He is also accountable for ensuring systems conform to applicable codes and standards, and for coordinating the work of installation subcontractors during construction and commissioning. Mr. Petro's recent projects include a 6.6 megawatt landfill solar array in Gloversville, New York, a 1.3 megawatt carport and rooftop solar in Wayland, Massachusetts, and 3.5 megawatt rooftop, carport, and landfill in Newton, Massachusetts. And then we also have Ed Bludnicki on the call, who is responsible for all commercial aspects in developing business and service solutions across commercial, industrial, higher education, and medical vertical market segments. He cultivates, qualifies, and initiates opportunities with clients, as well as serving as a lead agent to facilitate communication during all project phases. In addition, he monitors performance and engages in long-term relationship building across the full project life cycle. So we're thrilled to have these gentlemen join us today to share their expertise and give us a tour of Ameresco's school microgrid. We also have other reps from Ameresco on the call that'll be helping with the technology, and we hope that you all enjoy the webinar today. So with that being said, I'm going to turn it over to Jackson Dowdy if you'd like to begin the tour.
Hi, Brianna. Thank you so much for the introduction. We're excited to be here and really appreciate the opportunity with Cohasset to talk about this great project with Wayland. And also a big thank you to Wayland for allowing us on site today, even on a holiday, to talk about the project and go over all the details. So thank you again. To start, Brian, do you want to, or George, whoever's running the PowerPoint, go to the next slide? So just a quick agenda for today's discussion. We'll start with a quick overview of who Ameresco is and the work we do throughout Massachusetts and the country. We'll dive into details on the Wayland project that we completed a couple of years ago, including the solar installations and the resiliency controls. We'll go on to talk about a few other additional recent microgrid projects that have been performed for municipalities with Ameresco in the past year. To talk about the work that we've been doing with them and how different municipalities might approach these projects differently. And we'll finish off with a live Q&A to go over any questions or details that may have been left out during the discussion. Okay, let's go to the next slide. So a quick bit about Ameresco. We were founded in 2000 and went public in 2010. We've completed over $6 billion worth of energy projects, whether it's energy efficiency, solar PV, battery storage, cogeneration plants, a lot of different technology that we've done, just dependent on the customer's needs and expectations. We have over 1,000 employees spread across the US, as well as Canada and the United Kingdom. Can we go to the next slide? As mentioned, we're working with municipalities, C&I customers, federal and local government to deliver really whatever efficiency measures they need, whether it's energy efficiency or distributed energy systems for microgrid capabilities. We're doing all kinds of infrastructure work to ensure the clients are getting safe, reliable energy at an efficient price. Next slide. In terms of solar, we've been developing solar projects since 2010, meaning that we design, build, own, and operate, or can sell the asset to the client. This means that from the very beginning all the way through to commissioning and then operation, we are the one-stop shop for developing these projects to deliver renewable energy and energy savings and cost savings to the clients. We've completed over 275 megawatts of solar in operation across 523 completed installations. We have many more in the pipeline and are looking forward to talking through a couple of the projects we've completed today. Next slide, please. In terms of energy storage and microgrid, this has been something that we have found a lot of our partners have gained more and more interest in over the past few years. We have 22.5 megawatts of energy storage currently in our portfolio. This is spread across a number of different projects, including 4 microgrids for the US military, as well as several sites local here in Massachusetts. We have batteries in at Lexington schools, as well as Plymouth South High School, and then the microgrid controls today, which we'll be discussing for the Wayland Middle School. Can we go to the next slide, please? So to just give off a quick summary, Town of Wayland went into a power purchase agreement with Ameresco. We installed solar PV at a number of their sites, one of which is the middle school, where we will do a quick tour today. But this also includes the town high school, the city building, and the new Department of Public Works facility. All in all, we installed about 1.3 megawatts of solar, carports and rooftops. And again, today, the photo shown there is the middle school, where we're going to take a tour to look at the solar canopies that were installed, as well as the resiliency controls that went in. So now I'm going to try and start my video. Brianna, hopefully this will... Are you able to see me? Or
yes, we can see you. If you want to stop sharing your screen as well to the presentation, it'll blow up your tour.
Okay, here we go. All right, so I'm standing outside here. We're in the Wayland Middle School parking lot, where we're looking at the solar carports that we installed several years ago. So when we go into design work for these carports, we take into a lot of consideration. We try to work as closely with the town or our partner as much as possible. With these designs, we factored in a minimum height clearance of 14 feet. This was designed so that the fire department, as well as any emergency vehicles or snowplows, would have unrestricted access to the drive aisles and be able to navigate the campus as easily as possible. We did include LED lighting underneath the panels, which are used for safety mechanisms. I believe they're actually hooked up to the school's building management system so that they're on a timer to allow for lighting at night for teachers to gain safe access to their cars after the sun is set, and then are also able to be timed to turn off later at night to not disturb neighbors and so on in the middle of the night. These are Y-shaped canopies. These are designed to maintain rain and snow down through the center of the structure so that snow is not regularly falling or so on into the drive aisles in front of parked cars, in front of driving cars, and so on. I'm going to start walking down here. We're going to move forward to cut through the school to go towards the electrical room. The PV system is all having wire run underground, trenched underground to run through the school into their electrical room where it's tied in so that the actual solar energy is generating the credits at their electrical switchgear. That's also where we have our resiliency controls, which we will talk about when we get there. The project came about when the town decided to do a competitively selected RFP. They went out for public bid, and we were fortunate enough to be selected by the town several years ago when this project began. Let's see if I can. So I'm going to walk through the building right now. Let me get my Wi-Fi plugged in. Sorry, I'm just pausing it for a second so I can connect into the town's Wi-Fi.
Yeah, while Jackson gets that set up, this is Brian Petro. I just wanted to comment. So the lighting that we use on a lot of these canopies are dark sky compliant, which is a request for a lot of the towns we're working with. So that's something that we are able to integrate into the canopies. And then additionally, in a situation like this, where it's a front of the meter system, to maximize the financial benefits to the town, the lighting was actually pulled off of a building circuit rather than off of the solar. So the full credits of the solar are delivered through the meter rather than adding additional house loads in the form of lighting. So that's something that was integrated into the system and the layout to make sure that the town received the highest economic benefit.
Thanks, Brian. Yep. And so part of our design process when we go through permitting and discussions with the town, as Brian mentioned, items such as lighting. Another with this project was the need for resiliency. So the town had an existing diesel generator, which is still here today, and Hey, Brian, can you still hear me?
You're back now, yep.
Okay, sorry about that.
That's okay.
So so the town wanted to look into ways to reduce their carbon footprint in times of grid outages, as well as improve their own resiliency. As part of the solar project, we added in a resiliency controller, which currently is tying in the diesel and the solar PV. So I'm walking into the electrical room now. And essentially, we'll pull up a graphic to explain this a little better in a couple minutes. But essentially what's going on in the electrical room is that this ATS is sensing for grid outages. So in the event of a grid outage, the solar PV is reconnected to serve the school's load and is monitored and controlled by the fuel saver. So the fuel saver is essentially starting up the diesel generator, but is reducing the diesel generator's load when the solar is online, so that the school in island mode is able to use the solar as opposed to the diesel. Brian, maybe you want to take it over from here into, I think if you want to reshare the presentation, the next slides discuss the diagram of how the wiring works.
Sure. George, if you want to go, I'm going to go a little bit out of order, unfortunately, but George, if you want to share and go to slide 12, which is the operation during normal power single line.
Okay.
Right there. Thank you.
Yep.
So this is a basic single line of the system that is installed here. So starting in the bottom left is the PV system that is currently tied in through an ATS, and I'll discuss why in a second. The yellow highlighted line in this case is during normal operation, so the grid is running and the diesel generator is offline. The yellow shows how the system is connected. So in this case, the PV is connected and runs up through and connected near between the transformer and then the building loads. We don't show metering on here, but the metering would be between the ATS on the bottom of the distribution section and then the grid connection up on the top left. So 100% of the PV is run through a front of the meter utility meter. Then 100% of those credits are then applied to the account that's associated with the loads themselves. So in the grid connection box, the top, second from the top on the left, that's coming in from the utility. After the solar connection, there would be sort of where it says SW grid. That would show, that's where the meter would be for the utility. And then the power started through a second ATS and then off to the loads of the building, which is in the top right. The third box down the left that says SMA fuel save controller, that's the box Jackson was just showing. It's connected to the PV. It monitors the power output of the PV, which are the CTs on the bottom. It also monitors the power coming from the grid and the power coming from the diesel generator in the top. We don't directly monitor the loads because we are monitoring all of the power supplies. And so if you sum up the power supplies, that would show the loads. George, could you go back 2 slides, please? It's a little blurry, I apologize. But this is a graphic of the power production and consumption during normal operation. This was taken during commissioning. So in this case, this is with when the system was grid connected. The top right box shows that the building was consuming 327 kW. The way it runs in normal operation is whatever is available for the solar. So 100% of the solar is output by the system. If there's additional load required, so in this case, it was 149 kW coming out of the solar array, and there was 327 kW, which is the top right box, is being consumed by the facility. So the rest of the power, which is in the bottom left is the grid, was 178 kW, and that was fed from the grid. And you can see in the bottom right box that 327 kW total, about 45% of that was by the PV, and the other 55% was from the grid. In the event that the load dropped below the solar, you would actually put power back onto the grid, so you would net meter more to the grid than what was being consumed by the building. George, can you go forward 3 slides? Thank you. So this is during an outage. So the big change here is that the active power yellow line is now routed, rather than being routed over towards the grid, it's routed up behind the second ATS, which is the top ATS in the distribution section. And now the generator is being run. So the thing to note here is that because this was a front of the meter system during a grid outage, the first thing that would happen was the solar array would be disconnected from the building, and then it would not operate. So we had to install the bottom ATS to allow this system to be transitioned from a front of the meter system to a behind the meter system. And then it was connected to the loads and to the diesel generator, completely disconnected from the grid. And now, George, if you could just go back 2 slides. And this is an example of what would be happening during a grid outage. So the diesel generator is set, and it shows required reserve power 64 kW on the left. This was during commissioning, so that wasn't the final set point. But the diesel generator runs at a minimum of 120 kW, and that's to protect the generator. As long as the diesel generator is above 120 kW, the solar array would be allowed to output at full capacity to meet the demand of the building. If the solar array plus that minimum 120 wasn't enough to feed the building, then the generator would ramp up accordingly through frequency control. And if the generator dropped to 120 and the loads continued to say be reduced, then the solar array would be actively curtailed by the fuel save controller to prevent the generator from dropping below its minimum set point. In this particular situation, again, this is during commissioning, and you'll notice in the bottom left, there's no power from the grid, and the main circuit breaker status is open, meaning it's disconnected from the grid. The load of the building was 194 kW, 119 kW is being fed from the generator, and 74 is being fed from the solar. So it was 62% of the power was being fed by the generator, and the remaining 38% was coming from the PV. The PV, if there was more, if the load increased and the available solar was higher than say 74, that would creep up with the load as long as the generator was above that 120 kW minimum set point.
And Brian, an important piece here is that this control system went in at the same time as the solar. So right now it's the diesel and the solar, but there's opportunity now for, in future years, if battery storage or another technology was to be added onto the school's system, that could be incorporated as well. Is that correct?
Yep. Yeah. So you can actually see the graphics were set up for it. So there's battery powers in the summary block in the bottom right. And then you would drop a block in between the generator power and the grid power. And then depending on the needs of the facility, you would discharge that battery at certain times and charge it during other times, depending on, say loads of the building, what the generator is doing, and how much solar was available.
Great, thank you. And I think we've kind of talked a bit here. George or whoever's looking at the Q&A, do we have any written questions submitted?
No, not at the moment.
Not at the moment. Okay, great. So at that, let's go on to the next slide. Or up to, yep. So we wanted to talk about a few other projects in the local area, just because all in all, these microgrid projects and the idea of resiliency always means something different depending on who's really running the project. Towns and partners have very different needs in terms of what needs to stay online at all times, how long it needs to stay online, where their critical shelters and locations are, so on and so forth. So Ed, if you're on and available, could you please talk about the CVEC project?
Sure, Jackson. Good morning, everyone. This is a contract that Ameresco was just awarded earlier this month. CVEC is the Cape and Vineyard Electric Cooperative. They are a group of 21 municipalities out on the Cape that essentially pool their resources as an effort to kind of drive down costs. But really the goal of the cooperative is to focus on renewable energy or renewable technologies. They do work obviously in the solar PV. As you can see, there's rooftop solar at this particular site. They're involved in battery energy storage projects, which I'll get to in a moment. They provide the municipalities with assistance with electric vehicles and their associated infrastructure, namely their charging stations, and they also get involved in helping the municipalities with electric account management. So this particular project was a joint effort amongst a number of different parties. The first was CVEC, and as I mentioned, that's the Cape and Vineyard Electric Cooperative, the Dennis Yarmouth Regional High School District, and the Barnstable County Regional Emergency Planning Committee. Those three entities got together and applied for a DOER grant. That grant was run under the Clean Energy, or the Community Clean Energy Resiliency Initiatives. This was a program that was put on by the state through the DOER to look at various opportunities that were focused on resiliency, or in this case for emergency shelters. So they got together, they submitted an application, and they were awarded a grant actually a couple of years ago. And through working, they went out for a competitive solicitation. Ameresco was selected. We helped shape the solution, but in essence, they have existing solar, both ground mount and rooftop at the site today. We will be installing a 250 1,000 kilowatt hour battery and its associated controls. The controls will basically not only dispatch the distributed energy resources, namely the battery and the solar, but there'll also be an optimization whereby the controller will decide what is the best resource at that particular time. So it's going to look at things like the state of the battery charge, what output, if any, is the solar contributing, and then also there's existing diesel gensets on site there. So the controller, so in essence, what we have here is a small microgrid on the campus of the high school. What I think is really compelling about this project is that the battery is going to be a source of revenue, ongoing revenue for CVEC and the high school. The way that works is that through various utility programs, namely Eversource has a program called the demand response, a daily dispatch type of program, and through the RTO, namely ISO New England, this battery will be dispatched whenever it's not being used for resiliency or supporting the site. It's going to generate money for the high school and for CVEC. And I can say that it can participate in two different programs. Potentially, there's a third one coming on. And that revenue basically offsets the maintenance cost and then some for the battery. We expect the battery to have a 10-year life. So again, you get for the people at Cape, this is one of the regional emergency shelters. It's actually at this particular shelter, they prepare all the food for the other 2 or 3 shelters that are out in the Cape. So that's why this particular one was chosen. But again, like I said, is that what's nice about it is the people of the Cape get this resiliency benefit. This is a regional shelter, and then it's also able to produce revenue. So I think that really is the compelling point. You get a resiliency benefit, and it's also able to throw off revenue to pay for itself in outgoing years.
Thanks, and a couple of follow-ups. So you mentioned that contract was executed about a month ago, but if you could talk a little bit more about, we've really been involved in the development of this project for the past year or so. If you could talk a little bit about, the development of the design and working through how to integrate the solar and storage and how to integrate the genset, how to make it, the revenues work, and also the work we helped with securing the grant, that'd be helpful.
Sure. So, like I said up front, they went out for almost a year and a half ago, almost 2 years ago now, perhaps. CVEC went out for a competitive solicitation. Ameresco responded. At that time, we said, hey, you should maybe think about a battery at this site, and then a controller that, again, not only dispatches the assets, but again, goes through an optimization and decides what is the best asset to be dispatched at that time, coupled with the revenue generation. So we were able to look at, the technology, an optimization of that technology, and then, we thought to ourselves, how can we use this battery as a means to help pay for the project. So as Jackson noted, we worked very closely with CVEC and the high school for probably over a year. The contract was finalized, I think, about 2 weeks ago now. We're looking forward to it, but again, our, Ameresco's, we're able to bring through, guys like Brian and Jackson and myself, able to bring, a lot of know-how. And again, I think CVEC was very appreciative of that. Again, they're a cooperative. They're focused more so on green energy. So we were able to come in here and optimize the solution. And then at the same time, get it to provide a revenue stream. So they're delighted, as are we. We're really looking forward to this project. And again, it's a great benefit, for the people at Cape, the people of Barnstable County, the people of South Yarmouth. So, we see this as something that we could easily, replicate at other sites with the battery, with the solar, and the controller for the optimization.
Thanks, Ed. So we have a few questions, I think. George, are you able to see those?
Yes, Jackson. So one first question is, genset efficiency drops at lower power output. How do you optimize performance for that in your coordination with solar?
How do we account for the, okay, good question. Yes, so it's correct that, when diesels are running below nameplate, the further down they go, they are losing efficiency, which inherently does require more fuel for the same energy output. But the math that was done at the time of analysis, the time of development, showed that while there is an efficiency loss with the diesel genset, that the solar output is still a greater carbon reduction on a per kilowatt hour basis. Brian, does that make sense?
Yeah, it does. The approach might change a little bit if you had energy storage, in that you could keep the generator running at a higher efficiency. But generally speaking, since the solar is with respect to carbon is 100% efficient, it still makes sense to reduce the output of the generator down to the minimum that was for this project that was programmed in.
Excellent. Yep. And then is there another question, George?
Actually,
yes.
So before you jump into that one, I had answered a couple. I'll just run through them real quick, if that's okay. So
Sure.
there's
Yeah,
a question on dark sky lighting and what that is. So the International Dark Sky Association is actively promoting the use of fixtures that reduce light pollution, and that's mainly through focusing the light sort of downwards and making sure we're not overlighting areas, and that the lighting is being reduced whenever possible to prevent the light pollution that I think we've all become accustomed to. And there's if you want more information on that, it's www.darksky.org, and that's in the question and answers, which I think everyone can see now. I'm not sure. And then there was a question on whether the snow stays on the panels over the parking spaces. So yes, it does. Some systems on steep roofs will shed snow, but for these canopies, the snow does stay on the modules. As soon as there's a little bit of melting and some of the module is exposed, the cells tend to heat up and melt the snow rather quickly. So the canopies do end up melting off faster than say the snow on the ground. Particularly snowy winters, that record winter from a few years back, I think solar arrays throughout the state of Massachusetts were offline for like a month, unfortunately. But and then additionally, the canopies are designed so that any snow shed that does happen on these Y-shaped canopies happens towards the center of the array where there's no cars, so there's no damage or anything like that.
Great. Thank you, Brian. I'm not sure if we have more questions. I'm having a hard time seeing from my phone.
Yeah, here, I can read it for you. This is, I guess, for either you or Ed, but for the CVEC, the CVEC Dennis project, what entity determines priority of battery dispatch, revenue grid support versus local resilience, and does CVEC have the control?
Yeah, so the way obviously CVEC has the control because we'd never want to be in a situation where there was a grid outage and then the battery was called to participate in a some type of program either through the ISO. So that remains under CVEC control. Further, the program has some flexibility. There's actually a third-party aggregator that aggregates the output of multiple assets and applies those either to the ISO. But no, understood is that the first priority is always to serve the shelter if in fact there's a grid outage.
And there's one additional one here. Is it possible to structure or integrate a resiliency project into a community solar project? In the examples in Cohasset, we have the potential to exceed the municipality's needs and wonder if residents could off-take the excess power. If I'm understanding this question correctly, I think the idea is that during a power outage, to somehow I guess expand or allow say a community solar project to operate and feed whatever maybe local loads or residences in the area, and my gut feeling is no, that would be pretty difficult to get by the utility. In theory it's possible, but I don't think it would be allowed from a regulatory side.
Yeah, I think it's right. More so a safety issue, Brian, as you kind of point out, is that you have to basically isolate the facility from the grid, because the grid operator, whether it be Eversource or National Grid or some muni, their biggest concern is when they send somebody up on the pole, they want to make sure that that person isn't injured by somehow something backfeeding out through the grid. So I think unless there was some type of special switchgear or dedicated line adjacent to the facility, and even then that's probably somewhat problematic because the right of ways and such, and the franchised right of ways becomes somewhat problematic.
I found the Q&A section on my phone, so I'm looking at Steven's follow-up comment here, and so I'm wondering if the alternative answer is that aside from a resiliency project, if say the solar project was 2 megawatts, and in theory the town could take 1 megawatt of credits. If it was connected front of the meter, it could take 1 megawatt of credits. Could the other 1 megawatt go to residents as part of a community solar project? On that topic, from a public policy standpoint in the state, in theory that could be the case. The incentive gets a little strange from that perspective in terms of how who's the quote unquote anchor that's taking off most of the power, which would be the town versus residents who subscribed. So that may be a case by case basis, and maybe something we could follow up on.
Hey Jackson, it might make sense to work through the rest of the presentation and get to Q&A, and then we can
sure,
let people actively participate via conversation.
Yeah, I agree with that. Okay. If we can go to the next slide, George. So in Frederick, Maryland, we just recently finished mechanical completion of a solar array and battery storage system for the Ballinger McKinney wastewater treatment plant. The project is a 1.3 megawatt ground mount solar array with an 800 kW Tesla battery. The system was awarded to Ameresco through a competitively selected RFP. The county had received a grant from the Maryland Department of Energy to provide this resiliency system, this green resiliency system for their treatment plant. So the project is at the forefront is a microgrid goal of having the solar provide daily energy savings for the facility, as well as to charge the battery, which is outfitted with controls to black start the wastewater treatment pumps. From there on, it has about a 4-hour lifespan where the battery can fully power the system from the renewable energy before the grid is able to turn back on. Again, we finished mechanical completion earlier this year, and are currently awaiting for PTO from the electric utility. Let's see, George, we want to go to the next slide. And I think at that, we can open to the live Q&A section if that works for Cohasset.
Okay, great. So I'm going to allow all of the current attendees to talk. So if any of you would like to ask your questions live, feel free to just jump on in. You should be allowed to. I tried in the past to promote you all to panelists so you could show your videos as well, but it did not succeed. So you might not be able to start your videos, but you should be able to talk and ask your questions. So feel free to just jump on in.
Hi, Brianna. Can you hear me?
Yes, we can.
Okay, so I was asking a question about community solar. I guess from your answers that a community solar project should be totally separate from any kind of microgrid resiliency project. In Cohasset, we're considering several solar projects. The resiliency projects are, I believe, our top priority, but we also had the potential for generating more solar within Cohasset than the municipality needs. So we're wondering if we can have also a community solar project and whether there's any tie-in between these two types of projects. It sounds like what you're saying is it'd be much simpler to keep the two things totally separate. Is that correct?
In general, I think we would agree with that. One of the reasons why, so community solar, right, first of all, is a front of the meter interconnection type where all the energy goes to the grid and then credits are allocated to the subscribers' bills. Where we were at Wayland today is technically also a front of the meter project where all the credits are going to the town, and then switches to behind the meter during grid outages. The most community solar projects, the distinction is that the typical project is more of a larger ground mount where maybe there's not an immediate tied-in load that it could actually feed and back up, and it would require much more extensive overhead line work or reallocation of the energy during grid mode. Is that what you had in mind, or maybe you can describe the project a little more?
Well, Ameresco has been one of the bidders on projects in Cohasset, and we just noticed that if we were to add up all the generation capacity of all the companies that responded to our RFPs, that it would be far more than the municipality, the town facilities would need.
Right.
And so we were trying to figure out how we would structure this to get all the solar and have off takers for the power.
Okay, so in that scenario, it may make more sense for, let's say total there's potential for five solar projects, right? A few schools, a few parking lots, somewhere else throughout the town. What may make the most sense is for say 3 out of 5 to be allocated directly to the town up to what is deemed to be your capacity, and then the other projects independently are connected from the meter and pursued as community solar projects where let's say the town could receive a lease payment if it's on municipal land for the systems to be hosted there, but the energy could be allocated as credits to community solar subscribers.
Okay.
And
it would work through the credit system, solar renewable energy credits, right? Now, in your experience, would this make more sense than community aggregation? Which would be best for the residents? Say we're trying to get a aggregation program going, so the residents would have the chance to participate there, through the purchase of credits through the energy broker to get, say, 100% renewable energy. Would that generally be a cheaper rate for residents, or would a community solar project typically be better for the residents?
Unfortunately, I'm not an expert on the community aggregation. My immediate answer is probably that it depends, but I'm not sure if Ed or Paul are you on that may be able to help with that question.
I'm happy to chime in on this as well. This is Megan Aki with the Metropolitan Area Planning Council, and we do a lot of work with cities and towns on developing green municipal aggregation programs. And I think whether you're looking at green municipal aggregation or community shared solar, there are huge benefits to both. Obviously, with the municipal aggregation, you have the potential to impact all of your residents and all of your businesses in town by changing where your energy supply is coming from and increasing the renewable portion of that. Whereas with the community shared solar, you might be limited to the number of subscribers that you can bring onto the project. So the benefit is a little bit different in terms of the financial savings that folks would be getting from participating in a community shared solar project versus the benefit of participating in aggregation, where you're getting that renewable energy supply to all of the homes and businesses in your community.
And Megan, am I'm going into uncharted territory here. Am I correct in saying that technically the residents would be able to do both? If the town elected for community choice aggregation, could the residents still, because they're within the electric utility zone, be able to still purchase alternative on-bill credits? Okay, so they can do both. Okay.
They would be able to do both because the aggregation doesn't change where you're getting your electricity physically from, just the supply and what portion of that is coming from renewable energy sources.
So would there be any advantage to a resident signing up for both the municipal aggregation plus community solar? Would they be saving more on the community solar part?
Well, hopefully it leads to savings on both ends.
Yeah.
The goal of the community solar project is that the credits would arrive on their bill and they would be credited. I'll make up an example number. They'll be credited 20 cents per kilowatt hour, and then their bill to the community solar provider would be less than that. So it would be 19 cents, or I'm making up a number, but inherently through a community solar program, they elect to sign up because they're offered credits at a discounted rate, which is essentially locking in their savings on that rate. On the other side of the community choice aggregation, that in theory is able to allow the town to in bulk purchase their supply at a cheaper rate than they would normally be buying it from the electric utility.
Yeah, with the community aggregation, the resident doesn't actually get the credit for the solar energy credits. So that goes to the broker, to that firm. I believe I'm right about that. But with community solar, it's the resident who would actually get the solar credits.
That's correct.
Is that correct?
Yes.
Okay. And so for that reason, it may be advantageous for a resident to sign up for both, it sounds like.
Yes.
Okay. Gets rather complicated here, but
it is. It's uncharted territory with both the community solar and the choice. So it's fairly new concept, and the key here is how all this gets financed with both of these types of programs. That is still a path that we've got to go through right now.
okay. But the essential thing for today's insight, I guess, is that we should keep the microgrid resiliency projects totally separate from any community solar type project, and use, site by site, we should reserve sites for the resiliency projects that might take us up close to what the municipality load might be. And then any other site we could perhaps structure as a community solar type project.
Exactly.
That seems to be what we're saying here.
Exactly. Yep. Keep them
Okay.
clean, keep them separate. Yep.
Yeah, keep it clean. Okay. Simplify the all the administrative stuff and the financing stuff. Okay.
Exactly, because that's where the bigger problems will arise, is the separation of those two, because they work. As an example, if we have a community solar project, we're supposed to produce so many kilowatt hours, and those savings would go to the certain amount would go to the residency and the town. When you have the resiliency project, and then we have a whole host of logic that states that we're going to have to do A, B, C, and D to provide electricity for a resiliency event, it really causes a major issue in the contracts and the way that we would contract the community solar side. They're kind of two different things and difficult to do together under one contract.
Okay, thank you very much.
Yeah.
This is Munir. A question sort of along those lines. You know, most of, in fact, I think all of what you've shown are really single user microgrids. I guess Wayland is a little unique in that it is sort of a behind and in front of the meter character to it. But what do you guys see for the future of multi-user microgrids? You know, and it may be within a municipality, you may have different, you know, the police station and the community center and a low-income housing. So you sort of have different end users. You know, same utility and it's same ultimate owner in the municipality, but different meters, different customers in that regard. Do you guys foresee a future for that? And what are the barriers, if you know, to them today that you've encountered? Or
so we in fact certainly do see a future for that. I would say the biggest challenge today is getting the utility on board. The way the electrical system, at least in New England, it's done on a franchised right of way, meaning it becomes very difficult for a private group or individual or company to cross that without the utility's permission. And I can tell you generally, they're loath to do that. It's the essence of their business model. It grants them the exclusivity that the power grid, at least in this part of the country, that they have. So that's a significant challenge. That said, you know, Ameresco is working on projects in the greater Boston area where we are attempting to do just that. In other words, we will have various assets located at various buildings, and we'd like to be able to move that power to various buildings that either have assets or don't, that all would participate in that. So the important thing is to get the utility on board immediately. Get their, and typically it's you start working with their technical people. So, you know, they come up with a technical solution that is workable on their network, then it has to go over to their regulatory or their legal people. And that has been, you know, a challenge. The other thing is the economics of it. You know, who pays for what, who controls the microgrid, who dispatches these assets. Can these assets, you know, you talk about a blue sky day versus a dark sky day. How are those assets dispatched? So we do see a future. It's somewhat slow in coming. You look at some of the projects like down in New York City at Hudson Yards. I mean, they were granted a special utility tariff for the microgrid they have at that site. And again, that's very unique. That's certainly one way of going about it. But, you know, they probably spent about 4 years going through the regulatory process to get that special utility rate. So, you know, in New England, the best bet is to work closely with the utility. But again, you have to fundamentally get them to agree to let you cross a franchised right of way. And again, that's kind of the essence of their business. They grant them the exclusivity. Technically, we haven't run into many issues. In fact, the technical guys at the various utilities, they love this type of stuff. It's when it goes over to the regulatory side of the house that, it tends to get bogged down. There's a lot of, typical utility, you have engineers, you have weathermen because they live and die by the weather, and then you have lawyers. So the way it's codified today with ISO New England and so forth, and the federal, the FERC, there's a lot of legal steps that have to go through. And I would say the challenge is more so legal than it is technical.
Yeah. And Ed, I've been looking at, something like this for municipal utilities, municipal light plants who don't have that regulatory.
Exactly.
But
I've got a question related to that, if you'd like.
Sure.
So I'm in Concord, Mass, with Concord Light as our town utility, and in May we did a study with a meta grant to look at a virtual power plant for town resilience. So the concept would be, shelters, critical loads, and pumping stations for a storm event. That we would have these little microgrids for town buildings, like the police station, shelter, water pumping stations were critical, and that the utility, the municipal light plant, would be able to operate these battery backups as a virtual power plant for revenue to offset costs. Has that been done in the region? Is there a good example of that I can point to and mimic?
So and if you're talking about a municipality, I was familiar with a small muni in the state of Connecticut that did something similar. The state of Connecticut had some legislation whereby utilities were compelled to kind of look at these type of projects and grant that. I don't know of anything local in terms of a muni electric company doing it. The Cape is a quasi cooperative. It's not really muni, but they're starting to look at stuff like that. Connecticut, I think, again, there was legislation that promoted small type of microgrids, and I know at least 2 or 3 were built, and there was also some funding available through that program. But when I think about Connecticut, I mean, obviously what you describe is pretty straightforward. A municipal, a muni probably has a lot less. There'd be a lot less inertia to try something like this. Yeah, it has a lot less lawyers, and they may be more amenable to doing that. Yeah. However, I've dealt with other munis in primarily in Connecticut, and when I showed up, they weren't too happy with me because they kind of took the same mentality that, say, the investor-owned utilities do. That their life and their lifeblood is basically the franchise right-of-way that grants the exclusive access for them, and you can't really cross that. So
the good example here in Concord is that all of it is under the town manager's budget. So the MLP is an enterprise fund under the town budget. So all the the right-of-way problem should not exist here, because the people who own the utility are the same people that pay their property taxes. So we shouldn't have that within the distribution network in Concord. Once it goes to any kind of connection outside of the town to Eversource, then you get all the lawyers and all the problems.
Sure. No, I think and I think that's a very good point that you bring up, that if you can show that town manager that in addition to the resiliency payment, and provided that there's not a lot of extra protection, provided there's not a large capital cost to put infrastructure in place to isolate those sections of the grid, I think if you walked in and had a discussion with the town manager that says, hey, we're going to have these batteries, there's a resiliency benefit, and oh, by the way, we can generate through these 2 or 3 programs X amount of dollars for the program, I think you're going to have that person's ear. Because most.
I think Ed, the one thing to keep in mind is in most municipal light departments, they're the only ones that have the right to resell electricity within their borders. So if you wanted to do something different, it has to ultimately still be with the municipal light department involved. Very much like we did with Braintree Electric on the project down at their
Yep.
A couple
Oh
of
yeah, both the light plant and the town manager would definitely need to be involved because they one works for the other. So yeah.
Yeah, I think as far as, the financing vehicle, we're developing a number of microgrids across the country that we're actually willing to put up the capital to own and operate these so that the municipality doesn't. And it's more as an energy as a service where they're buying the resiliency more on a service basis versus investing in capital. But again, I think in that case, and we did this in Braintree, we actually own and operate the solar farm, but the municipal light department is really the clearinghouse. Everything has to go through them.
Right.
And which, quite frankly, I mean, if you look across the country, the co-ops and the communities have done a fantastic job anyways. I mean, the reality is that a lot of the co-ops communities are some of the lowest cost serving entities in the country on the electric rates. And this is, they're always looking for a way to improve their shareholder value, which is also their ratepayers, right?
Right.
So their interests are aligned. So at least our experience has been very positive. If you bring something to the communities or the light departments that will enhance their system, they're pretty much ears open on that.
Okay. Well, hopefully, I think it's Brittany. I apologize, but I'll send her an email and hopefully she can connect us.
That'd be great.
Yeah. All right. I don't want to take up too much time. Thank you.
Are there any other questions before we wrap up the webinar? I sent a couple messages into the chat, but I don't want to, shut down any discussion that we're having.
Brianna, I had one quick question. It was in the chat, but it actually didn't get answered, and that's with regard to controlling the battery at that Cape Vineyard project. Is there, how do they know? It could be a case where the utility draws down the battery in advance of an outage. They don't know that the outage hits oftentimes. So how is there a way that that's managed?
So Ed, you want to go ahead? I think he is asking if Eversource has control over for the demand response program, but that it's an opt-in program, so it's not something that they're required to do if instead they're preparing for a storm.
Correct, and we never the battery is never allowed to go below some minimum state of charge. So in theory, I think I understand your question. Would they could they be using that and then suddenly there's some type of event? I think that's possible. One thing about these programs is that heuristically you could go back and look at the data that says we are called every day from 1 until 3 o'clock. I think the events are maximum of maybe 3 or 4 hours. And again, the controller or basically the software that runs that looks at a number of different things, including the weather. I don't know whether we have a hook in there that says, hey, we've just seen a drop in pressure. Is there a storm front coming through here? Do we want to try and look at that? Typically the other thing is most weather services now have automated warnings and such. But look, I suppose it's possible, but then you look at, okay, well then we need to start the diesel genset to fulfill that requirement, or we need to bring the solar on, or if the solar isn't there, again it's a priority. So I think I understand your question, but I think there's a couple of things we have in there to try and avoid that condition.
Another design consideration, Ed, is I remember when we were going through development with CVAC and talking about the hierarchy of the controls and what they wanted as priority, was that we discussed setting a higher minimum storage capacity. In other words, if it's a 1,000 kilowatt hour battery, the town was considering adding into the controls to say it never drops below 500 kilowatt hours. We always have 500 kilowatt hours of available storage in case of unexpected storm conditions. I think at the end of the day, and Ed, you may be able to correct me, I think at the end of the day, they decided they didn't want to limit their revenue exposure, so they still allowed for the full battery to be used for revenue under the expectation that they would be able to at least see storm conditions coming due to weather forecasts if they wanted to pause revenue to fully charge it.
That's in fact the case today. And like I mentioned, we were just awarded this opportunity. I mean, we're still going through some optimization, but those are typically the type of things we look at, or we at least give in this case, the customer, what would you like to do here? Is it a revenue play or is it a resiliency play? And they have some input as to how they dispatch that resource.
Eli with utility here, and kind of chiming in a little bit on that, and tying back to some of the questions that Brian and Manir both asked. There's a lot more than just the weather that causes power outages in the United States and elsewhere in the world. Something like 15 or 20%, depending where you are in the country, of power outages have absolutely nothing to do with the weather. And in general, are equipment failures or rodents or insert kind of random cause here. So there's a lot of unexpected things that happen in the electricity supply world. And when you're operating these different sites, when you're designing these different sites, these microgrids or resilient power backing up islanding type facilities like we're talking about here, there's a real lot of subjective choices that need to be made in how you design it, how you operate it, and you have to tie into, kind of the market and financial aspects of the project, like Paul was talking about a second ago and Ed was talking about. You also have to take into account the physical design. Do you own the distribution system that you're transmitting power from the police station to the fire department? Or is that a publicly owned utility that connects the two? So there's kind of a lot going on there, and there's a real lot of kind of more subjective design decisions and operational decisions in these types of projects. And it makes it a very kind of confusing conversations to have sometimes, because there's really no one size fits all approach to this kind of stuff, especially when it comes to controls. If you want to reserve 50% of your battery storage at all times in case of a power outage, that might make a lot of sense for a project whose real financial benefit or social benefit is resiliency. It may make bad sense for a hospital where they want to reserve 100% of their battery storage all the time for resiliency. So it really depends on the application, and it certainly makes this type of work very interesting.
Yeah, so I don't believe there are any other questions, but feel free to interrupt me if anyone has a last second one. I am gonna kind of wrap it up here. I'd like to thank you all for joining us today, and thank you to everyone who came as a panelist as well. Ameresco, Megan, thank you for being here. I'm grateful that we were able to put this webinar together, and I think it's awesome to hear about this technology, and I hope that the more conversations we have about this, the more common it really becomes, because it's truly amazing. So thank you all for your work. Thank you everyone for being here, and I hope you have a great rest of your holiday. Yeah, and have a great night. Thank you, and please email me if you have any other questions.
Thank you all. Thank you, Brianna, for setting it all up. Thank you.
Thank you.
Yes, thanks, Brianna.